So today we've got no actual customer repairs, so we're going to look at one of the sets I bought recently from Andy of Vintage Audio fame, and it's the Grandstand Hawk, which uses the World Sound PT40 chassis. And just before I show you this Grandstand Hawk, I actually already own one which is in a box, so I don't know whether we've ever done this. It's on the pile of to be done. You never know, it could be another of those sealed boxes ones. Grandstand Hawk mic. So just to verify, it was a coffin mic. And it is a new set, and it's you can see it's got the power lead, and it's got the mounting bracket. So that's a useful mounting bracket to know about, because there's quite a lot of sets use the PT40 chassis and the side screw. So that's a forthcoming attraction of my own. We also get the instruction book, and there's a lovely Taiwanese square kit diagram. There's a lovely translation here which didn't quite go right. They are Taiwan, aren't they? No, it says printed in Japan. Right. I am lying. And it's telling you about the squelch control. I don't know whether this is... Yeah, they've got it right on this. It's another version of this set. It's one of the cheaper versions, which says in the squelch instruction, to receive the signals due to the phase chamber equality. Brilliant English. So that is one day going to be a forthcoming attraction. I'll put it back in its box. And we'll put it back on the shelf. So this one, I mean, Andy knows what he's doing. He's got the right test gear, but I still have to check. And because we're going to sell these on, they've got to be right in another way. Like, for example, we've got a power lead, but I haven't got a fuse holder in that. It's got to be addressed. So, Grandstand Hawk, jot down the serial number. Now, I like this chassis, even if nobody else does. There seems to be a pattern here. I like all the ones that nobody else likes. Is it like wanting the dog at the dog sanctuary, with one with half an ear? So we've got a bit of a thing I've previously done, because it's the Delta tune that is the killer to get right on these. Now these are one of the only sets where, when they were new, and this is in general on this chassis, when they were new, some of them had to be returned to be turned down because they were over 4 watts. You didn't get that, but you did with these. So Andy will have serviced it, but I need to do so again. So the wiring for the mic is standard Cybernet. I haven't put the soldering iron on, which I should have done. No, it's unpluggable, even better. Decent sized speaker. So a bit like the LCL communicator, this was an obsolete design when these were made in 1981. So if somebody had said to me, what kind of year do you think these were made? I would say 1977. Of course they were made in 1981. So it's an obsolete design, and that doesn't mean it's crap. It can also mean it's a well-proven design. There was a European version of this with like 22 channels or whatever at the time. Let's go put that into PA. And we'll get that connected up to our crocodile clips. There's quite a lot of sets coming in for service. I did mention there's another Thunderbolt 3000 brand new coming for optimisation. That'll be towards the end of the week. So we are starting with public address. So we'll get our mic plugged in. And we'll switch to PA. Testing 1 2, testing 1 2 3 4 5. What more could you ask? So we'll swap, take that speaker out, and now we'll plug in our test equipment speaker into extension speaker. And do we need an earth? Is it an isolated chassis? So if I remember rightly, they don't have a clever FM chip like more usual sets do. And the whole layout is unconventional. So there's 3 versions, 3 big major differences in these. The Lowe TX40 is a different board. It's got lots of similarities, but it has an extra stage in receive. And that is the best. Then the Grandstand Hawk, and any of the others that have got public address are your next one. And then the basic World Sound PT40, which doesn't have public address, is the most inferior one. And that doesn't mean it's an incompetent set. It's just the way you know, I perceive the kind of 3 generations of them. So, we will see what this one's doing. I think we're on low power. We are. Right, low, here we go. 4.4 watts. Channel 40, 4.4 watts. Channel 1, 4.4 watts. Low power. Back to channel 20. Got 520 milliwatts. Back to normal power, looking at the power consumption is 1.35. Deviation on this test set, won't take much notice of that. Wallow, this says 1.2, well it isn't going to be. We don't have a VCO method, but we could devise one if a radio proves to be problematic, because the synthesizer is the Sanyo LC7137. So our frequency at the moment, test set's not been on that long. $27,790.96, and that will come up. So our power meter on the radio, can we key it up and not short out my clip? is actually on the 4. I mean, it's nearly full scale deflection, but that's where the 4 is. So that is correct. Meter lamps lit, public address works, the sockets work, the switches work. I haven't checked all the potentiometers. So now we're going to put that frequency, 2779096, into our signal generator. So rather than the correct frequency of 2779125, 096 is because that's what it's working on. And we want this test to be fair. I don't remember these doing sparkling receive. That'll do. Take it the RF gains down. I'm quite right. The other thing I need to check is the delta tune is in the central position. It is critical on these. Anyway, it's switchable, so it is correct. We have to check the receive frequency separate to transmit. And it's a faff and a half. So let's look at the sensitivity. So go over to our SINAD meter. And it is doing 0.95 microvolts. .8 for 20. Squelch, put that to full. It is 3 millivolts. I'd like it a bit less tight than that, but there isn't a hard and fast rule on that. And then, might not be adjustable beyond where it is. So let's set the signal generator to be in standby at 0.3 of a microvolts. So we're putting the squelch on the radio. And that's not good. I'll just have another go at setting the squelch. It's about 3.2 microvolts. Now, I might be able to do something with the IF to improve that. So that's my only not happy about. Right. So if we look at my notes, of course it's not the same version, is it? No, I wouldn't expect that. I wouldn't expect it to be the same version. I think we'll be going back to the computer and nothing like. you've got the 1, 2, 3 there, the same. You've got that in the filter. You've got that, but not the one there. That one becomes there. So 1, 2, 3. Then our transmit ones look to be there instead of 1, 2, 3, 4. We seem to have got 1, 2, 3. And that coil seems to be now there. I'm going to have to now look at the service manual for the Lowe TX40, because I've got a sneaking suspicion this could be the same as the Lowe TX40. It's a long time since I've seen one. And that's why I have an A3 printer. Oh, let's have a look. Brilliant, it is the same. It's the same as the Lowe TX40, so it's the... well, it looks to be VR1 L14 L15. Just move that across so you can kind of see both. Chip there, preset there. The crystal L4, L1, L15, 11, 20, VR2, VR3, IC4, 17, 16, 2, that 15 and 14, VR10, VR11. It shows on here that the 12 and 13 are adjustable. They are adjustable insofar as, well, that one is adjustable, and that's an airspace one which can be fiddled with to get it right. I seem to recall that's the, I think to recall that one's the one for the harmonic. So it's the same as the Lowe TX40, and that makes it brilliant. I'm really chuffed about that. Of course, I'd like to do the boxed one as next job, but viewers don't want to watch the same ones twice, of course. So, just looking what it's supposed to do. If indeed they've got the received, but I'm not going to get that instruction book out. But I can print a copy off. What should you say? Sensitivity typically 0.2 microvolt for 12 dB SINAD, but of course the way we read that can be in EMF mode or the easy to achieve PD mode. So that, you know, let's put it in the easy to read one. So just turn that squelch down, not off. So at 0.98 or something for 12 dB SINAD, we'll put it into PD mode and readjust, and we actually get 0.48, so it's nowhere near what they say. Fair enough. So they do this a different way round to what we normally would do. My training is to do transmitter first, but of course you've also got to have done the phase lock loop. And I think what they're doing here this is all because of this delta tune malarkey. So they want you to go to channel 1, they want you to go to test point 1 and just L4 for maximum. So is there an adjustment layout? Of course there isn't. No. No, there's no adjustment layout. So test point 1. We've got to find test point 1. That's going to be ours, isn't it, this job? So this is going to be the synthesizer. Test point 1. There's test point 4. Test point 3. Test point 1. Test point 1 is there. And it's at one end of capacitor 68. It's got to be round here. They've got a way of finding stuff on these. Capacitor 68 has a B2 coordinate. B2, exactly the square I was looking at, and that's C68. And because it goes to L17, if we look back at the circuit diagram, one end of capacitor 68, and the other end goes to L4. So where's L4? L4, capacitor 68. There's a lot in between there, isn't there? So we've still got to find out which end's which. Was the end that doesn't go to the transistor? So when we look at the radio, should be there. Be handy if it said test point 1. I think it's that one rather than the far side, because the far side is going to be next to that transistor. Transistor 10. Looking back at the diagram, transistor 10. So it's going to be this pin here. Now, might be better off with an analog electronic voltmeter. I think we've got, instead of using the cheap Parkside one, I think we'll use the nearer £100 one, because I think it's got a bar graph on this one. So move the radio back across a bit so we can get that meter in. So it's not, we need to connect to earth. And we're in volts, and we're on that, and it says minimum of 300 millivolts. And we are adjusting L4, and L4 is that one. You know what, this meter still isn't what I want. I'm sure we've got one with a bar graph on it. I'll pause the video and get it. Okay, so it was on the floor in the chapel. This is a cheaper model than this, but it's got this feature. Perhaps the other's got the feature and I don't know how to work it. That's probably very true. What I really wanted was an analog meter like Hung Chang did, but is a FET voltmeter. So back to that test point. This time we've got a bar graph, and it makes it easier to adjust things like this. Mean hold or something? No. Could start by doing what the instructions say and say select channel 1. Okay, so wrong meter again. It says connect an RF millivolt meter. It's the big Russian meter. Can we get this massive probe down there? Okay, that's now set to maximum, which is what they were asking for. Connect a frequency meter to test point 1 and adjust CT2 to obtain 10.24046. Do not readjust L4. So we need to be connected to our frequency counter. Of course, if I did this every day, I wouldn't be pondering, would I? I'd just know what to do. So we have a reading 10.24029, 10.240, and they want 046. So they want us to adjust CT2, which is the crystal trimmer. So you can't set this to the transmit frequency like you normally can. I've overshot it. Okay, 10.24046. That's what it says. So now we've got to find test point 2, and we can use a multimeter. CT2. So that was test point 1. Test point 2 we now have to find. Test point 2 is the junction between resistor 3 and resistor 8. There's resistor 3, there's resistor 8. Resistor 3, resistor 8. So I would think that's our test point. See whether that works out. And we've got 1.95, haven't we? So what they want is, I mean, that's neither here nor there. That's right. And they want you to adjust CT1 till you get 2 volts. CT2. So we've done CT2 down there. CT1 is somewhere here. That one. I do not like wax in variable capacitors. There we go, 1.99 toggling 2. Okay. Now select channel 20. And now they want you to find test point 3, which is a junction of capacitor 63 and L2. Now there's L2. And there's 63. So chances are it's the lower pin. And there's 63. Yes, I think you can just about get on there. So they want 200 millivolts. And we're adjusting L2. L2 is where? L2 is there. In fact, that's not making any difference. I must be on the wrong side of it. Let's try that side. say it's just for maximum, which I've now done. With channel 20 still selected, connect the signal generator, which we've done. And what they have you do, because they're not expecting you to have a SINAD meter, they actually have you tune it up using the meter on the radio. They want you to put in what? They want you to put sufficient output for you to get S3 on the meter. So there we've got S3 on the meter. Now I'm going to put our SINAD meter up on the inset picture. Now it's okay for some of the IF stuff like this, but it's not alright doing the front end like this. So I'm just looking at what they're up to. L14, 15, 16, 17. Hello, what are we shorting out? 14, 15, 16, 17, 18 shouldn't be done that method, honestly. Because we've got an oversaturated signal. So I'm going to adjust VR3 to increase the sensitivity of the meter. VR3, that's 1, 10, 4, 4, 9. Come on, where's the others? What's that one there? 3. I'm going to adjust that so we have more sensitivity on the meter, like that. And then I can turn down the signal generator for a less saturated signal. Can I just get any more sensitivity out of that meter? That's maximum. Okay, so we'll use their method. We're still at 20 dB, and then I'll go through it with the SINAD meter as well. So 14, 15, 16, 17, 18, 19 and 20. So what we got? There's 15, 14, 15, 16, 17, 18. There's 20. I think that should be 19, shouldn't it? It shouldn't be 11. Because 11's there. That's a typing error. So 14. No, that's not an accuracy enough method at all. So that stuff what the service manual says, we'll go to what we're supposed to do. We look at the fine tuning I'm getting on that SINAD meter. That's brought it up a bit. $14, $15, $16, $17, tiny fraction there. Now 18, 19 and 20 I'm happy to do with the meter method because they're the IF. So we need more signal anyway, so we'll put it to 12 dB. So I'm going to look at it now on the SINAD meter, and then we'll go over to their method. Well, I think that's an improvement. And I think that's an improvement. And that's okay anyway. Let's see if we can see the meter. Okay, so that's what they say on. So I'm using the SINAD method for that. I'm using their method for that because I'm going to get a more accurate result. So that's covered that. Now we need to do L21, which is the detector, and this is where we're going to have to look at the oscilloscope, just connected across the speaker, as I've said loads of times before. An S9 signal, that's there, a meaningful waveform, and it's 21, isn't it? Where is 21? I'm looking for an FM chip. That's going to be, isn't it? Yep, it is. Absolutely spot on as it was. Turn the volume down. So now they're saying 1 millivolt for VR3, but it's 100 microvolts is the industry standard in the UK. And we need to adjust VR3 so it reads S9. S9 is there. Well, I'll tell you what, that's right, isn't it? So now we're to play with the squelch control. It's VR2. So VR2 is the other one down there. So I'm going to set the squelch to full. I've got the signal generator on 100 microvolts. We'll fiddle with that till it comes in, which is there. And now we'll do the sensitivity test. So park the signal generator at 0.3 microvolts. Let's put the attenuator up on the screen. Signal generator on. Nearly came in, didn't it? It's 0.9 for our sensitivity. So that's fixed that. And our tight squelch, let's put it to full, is 100 microvolts, which is what we want. Okay, so that's the receiver done. Out of interest, how on frequency is it? Or is that another thing? just slightly high. I'm not going to alter that. I've followed the method perfectly. Just get the signal generator to 25. There we go. Right, so connect an RF power meter, switch to transmit, make sure you're on high power and adjust 5, 6, 11 and 12 for maximum. So 5, 6, 11 and 12. And then you adjust for the 4 watts with L8. 5, 6, 11, 12. 5, 6, 11, 12. So that's what we're going to do. Now we already know it's doing just over 4 watts. I don't think the inspectors would nobble you for that. It's so let's just see where we are. Let's put the right meter up on the inset picture. That was absolutely spot on. That was absolutely spot on. That was absolutely spot on. We'll have to melt the wax in that one. I've only just put the soldering iron on as well. Neaten that up. And that was spot on as well. We're actually now doing 4.6 watts. It's come up a fraction. So now they want us to adjust L8 until we get to 4 watts. And it'll be tuned down. There we have 4 watts. Okay, what do the other channels have to say for themselves? Channel 40 says 4 watts. Channel 1 says 4 watts. And it was balanced before. It's balanced now. We haven't finished. There's still some things to do. But I can fill this in now. So it's now 4 watt, 4 watt, 4 watt. And our current consumption is 1.306. 1.306. So you can't see there's much difference. It's down a fraction, but you can see it was tuned right in the first place. But it was just that little bit too high. So what are our other things to do? Oh yes. Transmit, press transmit and adjust VR1 until it actually reads S9 on transmit. So what does that correspond with? Oh, because the power is 0 and 1, that's why it's not calibrated for, it's just kind of 3/4 across. Yeah, I can see what they're doing there. So VR1 is the preset at the back. So let's see when we press transmit, so it actually wants to come back to that mark there. That's what the book says. So that's that done. Now here's the complicated one for transmit. It's delta tune. Ensuring the delta tune is off, adjust the preset with the frequency counter to the aerial output on channel 20. And we need to preset 9 is that one. So delta tune is off. So it's just our transmit frequency trim, folks. Yes, it is. That's where it wants to be, so that's fine. 198, 128. Good. Then we're going to adjust VR10 until the power output on low power is 0.4 of a watt. So it was a little bit high before. So VR10 is the one at the back there. So we'll go to low power. And it wants to be on everything except 400 milliwatts. There we go. And we now know our transmit frequency is 79. So put the frequency counter up. 128. So they've had you set the receiver up using mathematics, effectively, from how this is computed with the synthesizer chip, and then they've had you trim it with the Delta Tune preset. With a sustained whistle at a 1 kHz tone, adjust the preset VR4 for an absolute maximum of 2.5. Well, that's what we do. If you're doing this at factory level, of course you do it in through the mic socket, but only if you're doing loads of sets the same. So VR9 is deviation, and no, VR9 is Delta Tune. VR4 is that one. So we'll go to the test set behind. I'll switch to the main meter on this one, ready. I actually am going to be interested to see what I've got sensitivity wise. You can see why these people don't get on with these radios. They're so complex to do the alignment that most people, they don't have this information, do they? They weren't subscribed to Wireless and Electrical Trader in 1982 like I was, hence I got the manual. You know, I paid for that. Wallow. That's it. I was absolutely fine where it was, but we just can have that little bit more as a peak. And then we'll see what it says on my Marconi test set. See whether the deviation meter is lying today or not. Oh, exactly the same. So it's not lying today. So it was 2.2 kilohertz. It's now 2.2 to 2.5 kilohertz. So we've done the RF meter. We've done the S meter. That was correct before. It's correct after. What else have we got to do? We've done the deviation. Check using the frequency counter that the frequency for each channel is correct against the table. Well, I'm really going to go through 40 channels, aren't I? Well, we check 1, we check 40, we check 20. And we listen to 19. And if a spectrum analyzer is available, check that the transmitter signal is clean and free from spirit emissions. Now, what we do there, we've got the spectrum analyzer, but you've got to appreciate there's the cost of the time involved. That's an extra 5 minutes on the job. So what we do, unless it's a set that's been made out of junk, we're going to assume it's not being messed with. What happens is, when we do the scratchy corner test, when Mr. Chippie goes around scratchy corner, he knows what a set doing 4 watts should sound like. he will say to me, and he does say to me, are you sure that sets on full power? Are you sure the aerial socket's clean? All those kind of things. That's when we'd look back on a spectrum analyzer. So that's that. So any more pages? How to dismantle it. Yes, it's the circuit earth and not the chassis. Equipment required. 2 amp power supply. You see the multimeter they were using was only 20 kilovolt per ohm like a AVO 8. Frequency counter, that's why we're getting some higher results, because we weren't using the specified meter. Could have got out an AVO 8 because we've got one. Frequency counter, RF power thing, deviation meter, RF millivolt meter, we've got all that. There we go. Well, I reckon we've done that, and that is going to be splendid. And so really I should do my other one, but while I've got it in my mind. So that is definitely the PT40 and not the Grandstand Hawk. So this is, no two ways about it, it's exactly the same as the Lowe TX40. So it is the best version of these to have. Yes, I want to do this bit next. Let's see whether we've improved the sensitivity, because going through all that in such meticulous detail, I think we're going to have got a better result. So let's put it on, go over to the SINAD meter and see whether I've fixed it worse. (12 dB), 0.37 microvolts, 10 dB, no, I've written that down wrongly. It's 0.45, 10 dB, 0.38, 20 dB, 0.75. That wasn't 0.48, was it? It was much higher than that. I don't even know what that was. I wrote it down wrongly. So I think, yeah, I've just done this all wrong again. I've had it in the easy to achieve one, haven't I? So back to the harder to achieve. We've now got 0.85. (10 dB). Now got 0.74. 20 dB is now 1.35. So 0.85 is what we've got. So it's still nowhere near what they said, around about 0.2 on the easy to read scale. So there we go. So we've got a set with the same kind of sensitivities you'd expect out of a Uniden. And I'm looking forward to playing with this on Scratchy Corner. So apart from putting a fuse holder in that, I'll have to see whether he sent a mic with this, but we'll worry about that on the air test, because we've got a box of mics to go with the 22 sets I bought from him. Put the speaker back on. Right, switch that off, and we'll plug our roof aerial in. So it's the Antron 99. I'll just pop the squelch on for a moment. Just put that meter away so it's out of the way. I think I deserve a kip after this. What do you think? Going to check the springiness of the connector before Mr. Chippie says, have you checked the springiness of the connector? It's a nice, I mean, it's been used, it's 40 years old, but it's nice condition. That's the ceramic tool on the floor. One on a Roger. Notice the FM actually sounds different to how it was when it came in. Well, I don't know if that's going to say anything at all today. There we have it. Grandstand Hawk from 1981, which turns out to be the Lowe TX40 in disguise. Thanks for watching.